Alright, so we're going to look at inequalities. And inequalities are anything that uses greater than, less than, greater than or equal to, or less than or equal to. So I'll make sure I have and less than or equal to. Alright, so we have inequalities written. And what we're going to want to do is we're going to be able to graph these on a number line. So let's give a basic number line here. Which will have some 0 in the middle. And it goes off to positive infinity in this direction and negative infinity in this direction. And it can house all real numbers. And so if we look at set builder notation, and I say that x such that x is less than a, what that means is I have some a somewhere. And so I'll actually put a here in a reference away from 0. And so it's less than a. So I draw an open circle. And then I color everything in less than a. So I fill this bar in. And I put an arrow pointing at it. And this represents all numbers less than a. But this circle has to be open. I don't want anything in that circle because I need to say that I'm not at A, because the less than has not at A. So we're going to do all the possible examples we can get here. So I'm going to alternate colors as I work my way through. And let's come down, do another number line. We'll put negative infinity here. Positive infinity here. We'll look at A, and in set builder notation we'll look for x less than or equal to A. Now less than or equal to, so being equal to A, put a dot on A and I fill in the dot, and then I color in everything less than A and give it an arrow because it'll keep going off to negative infinity. Now we're going to see, what we're going to do is we're going to work our way through every possible combination of these that we can get so that we have a feel for what these things look like, and then we'll attach particular numbers to A. So positive infinity here, negative infinity here. I'll continue to put A in the middle. And so in set builder notation I'll have x such that x is greater than A. And so I have an open circle. Make sure there's nothing colored in the circle because it's not at that point. And then it's everything greater than. I don't know what A is. A can be any number. But we know that if we see this notation for it, that's what it's going to look like. And this coloring in and this arrow represents everything off towards infinity. Okay, let's continue on. And again, I'll have negative infinity down here, positive infinity here, and I'll put A in the middle. And in set builder notation, x is greater than or equal to A. And so since I have equality, I fill in my dot, and I go off towards infinity. And so we're having ways of talking about when things aren't equal, and the possible solution it represents multiple places on the number line. And so we fill that in to visualize it. Let's look at what happens if we have two numbers that we do our comparison with. So let's turn towards, let's see, I'll do a purple. Again, I'll keep the pattern of having negative infinity down here, positive infinity here. We're going to have an A and a B. We're going to ask in set builder notation what happens if X is greater than A, but less than B. Now notice what happens here. Wedged in the middle here, X is bigger, because the bigger ends of the greater than, or of the less than. And I always say it points to the smaller thing. And so X is wedged in between A and B in this notation. Or in this case, we're looking at everything in here. What I'm going to do is I'm going to slowly update this notation. So again, using a number line, putting negative infinity and positive infinity, A and B, and we'll use set builder notation, and we'll say that A is less than or equal to X, or I'm sorry, A is less than or equal to X, which is less than or equal to B. Because we have the equality signs, we'll fill in our dots, and we'll color everything in the middle. And this is telling us that the possible values X can have are between A and B, anything between A and B, including A and B. Well, this one says it's anything between A and B, not including A or B. And we could have equality on either endpoint. So I'm going to update this here. And let's say I put my equal sign here. Well, then I would fill in this circle. Or, let me scratch that out. And let's say that instead of having the equal sign here, I'm going to put it here. Then I fill in this circle. And so we have a way of talking about sections of numbers based on if things are equal to or greater than or less than another value. Well, we can think of these as boundaries, and how these boundaries interact can work like equations. And so we can have linear inequalities. And a linear inequality in one variable looks like this. Now notice this is the same form as a linear equation in one variable, but in place of the equal sign it has an inequality. But what's nice for us is that these end up acting exactly like an equal sign, because these are mathematical statements. This says ax plus b is greater than 0, and we assume it's true, and we manipulate it so that we can say something about x. And if we do follow our rules, we're able to then, our rules of properties of real numbers and properties of statements, and we treat the left-hand side and the right-hand side equally, just like we did with equations, this statement will change to something true. So let's use an example to see what I mean here. I have an inequality, but I want to find all values of x for which this is true. So I will treat the left-hand side and the right-hand side as if there was an equal sign in the middle. And what I'll do is I will add 7 to both sides. And so a -7 plus a 7 cancels. And now I'm going to divide both sides by 3, or by 4. Feel like I'm in a Monty Python sketch. And so 4 over 4 gives me x is greater than 3. And so I've solved this linear inequality by doing the same thing I would for an equation, using the inequality sign as the boundary between the left-hand side and the right-hand side. And I get an answer that on the number line looks like this. It's everything greater than 3. And so we call this solving a linear inequality. All right, in the next video, I'm going to work through some samples of these and work on different solving of linear inequalities. Notice that the concept isn't a huge jump from equality. And I want to do one more before I switch over, and it has to do with what happens when the negative sign comes across. So I have negative 3x is less than 21. And something happens when the negative sign gets applied. I likened it when I was a kid. I used to think these were alligator mouths. And when a negative sign would divide through, it was like a hook that pulled the alligator mouth the other way. So what I want to do here is I want to divide both sides by negative 3. Which will give me x is. But when the negative comes through, it's going to change the direction of the inequality. And so that's something we have to keep in mind, is that when we are dividing by or multiplying by a negative across an equal sign, it changes the direction of the inequality. So when we're dividing or multiplying a negative across an inequality, it changes the direction of the inequality. And so this one's an open circle, and everything bigger than that. And oops, that has a negative sign on it. Let me fix my graph then. Notice what I forgot to do. When I divided, I forgot a positive divided by a negative is negative. That's an easy fix. And so I'll re-update my number line here. So it's negative 7 and everything bigger than it. Alright, I'll continue to do some more examples of these, and we'll practice and we'll make this work as we'll be solving linear inequalities.